All right, this video is going to show you how to balance by half reactions. So last video, you learned how to balance by oxidation numbers. This is a different method. You're going to find some of the steps are going to be similar, but the order in which we do them and how we do them is kind of different, okay? So I'm going to walk you through the steps you're going to take, and then we'll look at 3 different examples to show you how this is going to look, okay? So step 1 is going to be to split the overall reaction into 2 halves based off of the elements. So that's just like what we did on the first lesson of this unit, right? We looked at it and basically we were like, oh, this has zinc. Zinc's going to go into one half, and then, I don't know, iron is going to go into the other. So we're going to do the same thing here. We're going to look at the types of elements we have, and we're going to split it into 2 separate half reactions. Okay, once we have split it up, we then need to individually balance each of those half reactions. So first thing we're going to do is anything that is not oxygen or hydrogen, we're going to take care of balancing those. So like if we have Br2 on one side and just a Br on the other, we're going to put a 2 in front of that to make it balance those 2 bromines, okay? Once we have done that, if we needed to, we are then going to take care of oxygen by adding water, right? So that's the same thing that we did in the other method, but we're doing it at a very different stage, right? In the other method, we did that near the end. Now we're doing that at the beginning. So we're going to add water to balance oxygen. Then we're going to balance hydrogens by adding hydrogen ions, okay? So in this method, we take care of balancing atoms first. Once our atoms are balanced, which we now have done because we balanced everything that wasn't O and H, then we balanced O, then we balanced H. Now we're going to balance our charges. So just like we did when I first introduced you to writing half reactions, we're going to figure out what's the charge on the left side, what's the charge on the right side, and then we're going to add electrons to make them the same. Okay, so either to this side, that side, we will figure out what it's going to be. Okay. Then what you need to do is we need to combine our 2 half reactions. To be able to combine them, we have to make sure that our electrons are going to cancel out. So we're going to look at what we have. We're going to figure out what we need to multiply by so that we have the same number of electrons in both of our half reactions. Once we have done that, we're going to combine the 2 half reactions. You should find that your electrons at this stage are going to completely cancel. If they don't, you didn't multiply by the right coefficient, you need to go back and fix that to make sure that your electrons are gone, because there shouldn't be any electrons in that final equation. Okay, the other thing you have to watch for in this method is not only should you be canceling electrons, but you may also find that you can do something with your waters and hydrogens. Sometimes you can eliminate, sometimes you can reduce, sometimes you have to combine. Okay, it really just depends what side they're on. If they're on opposite sides, you're either going to eliminate them entirely if they're balanced with the same coefficient. If they're different, like I have a 10 over here and 6 over here, I would get rid of the 6 and I would turn the 10 into a 4 because 10 minus 6 is 4, right? If they were both on the same side, so I had like 2 waters and 4 waters and they're both on the same side, I would combine them to make 6 because 2 plus 4 is 6, okay? Once you do that, check to make sure it's balanced, right? Check to make sure your charges are balanced, your atoms are balanced, and that you have the most reduced form. So this method takes a little bit more time to generate that final answer, but usually you guys are a little bit more consistent with this method, okay? And I think that's why a lot of you tend to prefer this method over the other one. Because you're like, oh, I get the answer right most of the time when I do it this way, whereas the other way, even though it's less work, maybe you're a little more hit or miss with getting that answer right. So ultimately, you should get the exact same answer regardless of which method you use to balance, because you can only balance an equation one way, right? Like there's only one correct version of a balanced equation. So if you find that you're trying to balance an equation using one method and you're really stuck, you can always try using the other one and see if you can come up with something different doing the other way. And if you find they both work, right? Sometimes I'll see you guys, and this is more so when we're in class, a little different, we're at home, but sometimes when we're in class, I'll have people be like, hey, Miss Chip, I got this answer and my friend got this answer and they both work, but they're different. Not possible. They can't both work and be different. There's only one right answer when it comes to balancing, okay? So let's go through some examples where we walk through what these steps are going to look like. Now, this may be a little challenging for me to do because I don't have the biggest screen, but I will definitely do my best. Normally, this is where I would switch the smartboard off and go to the whiteboard where I have lots and lots of room to write, just because I don't want to say it gets messy, but you kind of start with something and then you're adding. So how you choose to approach this can vary. So first step will be the same regardless of what you do. And that first step is always going to be to break this up. So I need to take this whole reaction and create two halves. So the H2C2O4 is going to go into one, and I'm going to pair that with the CO2, right? Because I don't want to pair it with the Mn because I'm never going to be able to actually balance it. The Mn is going to get paired with the MnO4 minus. Oh, I see a delivery truck. Maybe it is my new patio set. Hold on. It is not. It's my children's scooters. They're excited. I am, I guess, kind of excited because it means they're going to go play outside and not be yelling in the background. All right, so back to this question. So we are going to split it. So we are going to find that the H2C2O4 is going to go into an equation with the CO2. Okay, and we are doing that because they both have the C. Our other half reaction is going to be the MnO4 minus with that Mn2 plus. Okay, so here's our two starting frames. So why I said you kind of have a couple of options of how you choose to do this. Some of you like to deal with one equation and go through all the steps with that one, and then move to the second one, go through all the steps with that one, and then add it up. Others of you are like, you know what, no, I just want to do the same step to each one as I go. Both are totally fine. You can do it either way, whichever kind of works better for you. So we have now split it up. Our next step is going to be to take care of balancing the atoms that are not O and H. So when I look at this one, I have C2. I only have one C over here. So we're going to add a 2 in front of the CO2 to take care of that, right? Now our C's are balanced. We have 2 and 2. We then can look at our second equation. Well, we have one Mn and one Mn, so we don't have to worry about that step for this one. Okay, our next step is to add waters to balance oxygen. So when we look at our first half reaction, I have 4 O's and I have 2 times 2, so I have 4 O's here as well. So my oxygens in this are already accounted for. I don't need to add any waters. But when I look at the MnO4 minus and the Mn, I have 4 O's on this and I have none on this side. So we're going to fix that by adding 4 waters. Right now we have 4 O's matching our 4 O's. So next step is to take care of our hydrogens. So go back to the first equation. I have 2 H's on this side. I have none on the right side. So we are going to have to add 2 hydrogen ions so that we have 2 H's matching 2 H's. In this equation, we have no H's on the left side and we have 8 over here on the right side. So we are going to have to add 8 hydrogen ions over here. Okay, now we've taken care of balancing all our atoms, right? We took care of anything that wasn't O and H, then we took care of O, then we took care of H. The next thing we need to do is we need to balance those charges. So I look at this side, there's no charge written here, so the charge is 0. We look at this one, there's no charge with the CO2, but each of my hydrogens has a +1 and I have 2 of them. So on this side, I have +2. Okay, you have to make sure that you don't forget to account for this coefficient when you're figuring out the charge. So we don't have equal charges and we shouldn't. If we find we reach this stage and we have the same charge on both sides, something has gone wrong because that it's not a redox equation and we would not be asking you to balance it, okay? So it always should be different. So how we're going to fix this? Same way we fixed it when we looked at writing half reactions at the start of this unit. Because we have a 0 and a +2, and every electron has a negative charge, we are going to, hold on, I want to add to this. We're going to add 2 electrons, right? So now that makes the charge on this side equals 0, which is the same as the charge over here. They're both going to be 0. Okay, we need to do the same thing in this equation. So when we look at this one, I have 8 positives coming from this. I have a negative here. So that means I have +7 on this side. Okay, because 8 times 1 is 8, and then -1 is where that 7 is coming from. On this side, the water has no charge. I only have 1 Mn, so I have +2 on this side. So, got to add my electrons. If I have a 7 and a 2, I need to add 5. They have to go over on this side, right? So that it brings my 7 down to 2. So some things you should find. They should always be on opposite sides. Either they're on this side and this side, or if it was over on this side in the first equation, it would have to be over here on this side in the second. If they're both on this side, or they're both on this side, you have made an error and you have misassigned your charges. Usually what has happened is you've forgotten to take this like coefficient into account, and you just went, oh, positive, negative, this is 0, this is +2, I need to add 2 electrons over here. So make sure you don't forget about those coefficients when you are doing that, okay? So once we have created our 2 half reactions, our next step is going to be to combine them. So basically we need to add these 2 together. But to add them together, we have to make the electrons the same. Right now I have 2 and I have 5. That is not the same. So I am going to have to multiply the first equation by 5, so I can get 10 electrons, and I'm going to have to multiply this one by 2, so that I can get 10 electrons as well, right? We need to make sure that those coefficients are the same. So when you do this, either you can put brackets around the whole thing, your number out front, or you can choose to just add those numbers in as you go. Usually it tends to be a little easier to just literally put the numbers in, because otherwise what happens is by the time you get all the way over onto this side of your equation, you forget that you need to be multiplying by those things. So what I would do is I would go in here and I would say I need to multiply this whole equation by 5. So 5 times 1 is 5. This is going to turn into a 10. This is also going to turn into a 10, as is this, right? Because when we multiply all of those numbers by 5, that's what we come up with. In this equation, we're going to multiply by 2. So that's going to turn this into a 10. 8 times 2 is 16. 1 times 2 is 2. 1 times 2 is 2. And 4 times 2 is 8. Okay? So now what I want to do is when I go to add them, I want to figure out what I can get rid of. So I should always find that my electrons cancel completely. If they don't, I haven't done it properly. So to cancel completely, they need to be on opposite sides with the same number. Okay, the other thing we talked about looking for was your waters and your hydrogen ions. So in this case, I only have water in this equation. I don't have water here, so I don't have to worry about that. But I have 16 hydrogens here and I have 10 over here. So they're on opposite sides, so I'm going to reduce them. So this 10 is going to cancel. And this, if I do 16 minus 10, is going to just turn into 6. So what we're left with is going to be our equation. So everything that was on the reactant side, we're going to join together on the reactant side, and everything on the product side is going to join together on the product side. So we are going to have 5 H2C2O4 plus 6 hydrogen ions plus 2MnO4 minus. Okay, that was all we had on the reactant side. Product side, 10CO2 plus 2Mn2 plus 8 waters. Okay, so do you see what I mean? But it was a little bit more work. but it tends to be a little bit more consistent. You don't really have to do the oxidation numbers, so it tends to have a little, I want to say a little less room for error. You still definitely can make mistakes. Usually the mistakes you guys make with this is when you're counting the charges on each side. You make silly mistakes counting the charges, and then you don't put the right number of electrons, and then obviously it's not going to work. So most important step, let's make sure it's balanced. Let's also make sure that we can't reduce it, okay? So hydrogens, I have 10 plus 6, so I have 16 hydrogens. I have 8 times 2, so I have 16 hydrogens. 5 times 2 carbons, so 10 carbons, 10 carbons. Oxygen, I have 5 times 4, so 20, plus 2 times 4, so I have 28 oxygens. Here I have 10 times 2, so 20, plus 8, so I have 28 as well. We already did the hydrogens, so the MNs, I have 2 MNs as well as 2 MNs. So those all balance out. So my atoms are currently balanced. The next thing for me to check is my charges. So I have 6 positives and 2 negatives. So 6 minus 2 is 4. I look over here, no charge, no charge. 2 times positive 2 is also plus 4. So my charges are balanced, my atoms are balanced, and when I check my coefficients, I cannot reduce them, so we have correctly balanced this. Okay, let's try another one. So Mn2 plus BiO3 minus to give you MnO4 minus and Bi3 plus. So same steps, we're going to start by splitting it up. So we're going to do Mn2 plus turning into MnO4 minus. Then we have BiO3 minus turning into Bi3 plus. So 1 Mn, we don't have to balance the Mns. 1 Bi, we don't have to balance the Bi's. So we move to balancing oxygens by adding water. We have 4 O's, so we're going to add 4 waters. Here we have 3 oxygens on this side, none on this side, so we are going to add 3 waters. Okay, so now our O's are balanced. We need to take care of H's. So I have 8 H's over here. I have no H's over here. So we are going to add 8 hydrogen ions. Okay, in this one, I have no H's over on the left side. I now have 6 over on the right side. So we are going to add 6 hydrogen ions. So atoms should be balanced. Let's take care of our charges. So when we look, we have plus 2 on this side. This has a -1 and 8 positives. So -1 and 8 positives, I have plus 7. So to take care of this, we need to add 5 electrons. I'm just going to make this actually into a superscript because apparently I didn't do that. There we go. Okay, so same thing down here. We look at this. I have 6 positives from the hydrogen and a negative, so I have plus 5. And then on this side, I have plus 3 from the Bi. There's nothing from the water. So we are going to have to add 2 electrons so that we have plus 3 on this side, right? Because plus 5 minus 2 gives us 3. We now have balanced out those charges. So now that we've done that, we are going to combine these 2 to give you 1. So I have 5 electrons and 2 electrons, so similar to the last one. So that means I have to times this first equation by 2. So I'll show you the other way of doing it, right? I was talking about not changing the individual numbers. So the other way you can do it is just kind of write it out like this. Okay, the challenge with writing it this way is you have to make sure that you remember by the time you get over here that that 2 applies. So if you want to actually just write it in the same way we did with the last question, you are definitely more than welcome to do that. I just want to show you this way so that those of you that are like, no, I want to do it the other way, get to see an example like that, okay? So we should still find that our electrons fully cancel because we have 10, right? 5 times 2 is 10 and 2 times 5 is 10. So my electrons are going to cancel. Okay, in this case, I have to look at my hydrogens. I have hydrogens here and here. So this is where I have to make sure that I don't forget about those coefficients, right? I have 2 times 8. So really I have 16 of these. And here I have 5 times 6, which is 30. So if I have 16 and 30, right, we are going to find that we are going to have, I'm doing it in my calculator to make sure I'm doing this right. Sometimes we do math in our head and it turns out well, and sometimes we do math in our head and it doesn't turn out well. We are all guilty of that. So you can use your calculator, right? Sometimes when you guys don't use it, you make stupid math mistakes, and then you wind up getting a question wrong, and then when you look at it again, you're like, why did I think that this times this equals that, okay? But there's nothing wrong with doing it in your head. There's just also nothing wrong with double checking that you've done it right, okay? So these are going to fully cancel, right? Because we had 30 and 16, and 30 minus 16 equals 14. Water-wise, we also have water in both equations, right? So really here I have 8 waters, and here I have 3 times 5, so I have 15. So again, they're on opposite sides. These are going to fully cancel, and I'm going to find that I'm going to do 15 minus 8, so I'm going to have 7 actual waters over here. And so this is what I was saying, sometimes it's just easier to like multiply everything through and change those numbers. This is another way to do it, but you still have to make sure that you are accounting for a lot of those things. All right, so now what we're left with, we are left with 2Mn2 plus 14 hydrogen ions plus a BiO3 minus. Oh, no, see, and I already made a mistake. It should be 5 BiO3 minus because I have to multiply that 5 through, right? So that is the danger of not putting all those numbers in. I don't want to say it's the lazy way around it, but in a way it is, right? Because I'm not changing every single number, but then I have to make sure that I'm not forgetting to apply that through. Okay, product-wise, we have 2Mn O4 minus. All the other stuff in that first equation canceled. We have the Bi3 plus, and we do have 5 of those. So plus 5 Bi3 plus. And then we said we had 7 waters. Okay, so let's make sure it works. 2 MNs, 14 hydrogens, 7 times 2, 14 hydrogens, 5 Bi, 5 Bi. 5 times 3, so 15 oxygens. 2 times 4, so 8, plus 7 is also 15. So atom-wise, we are good. We need to check charges. So this side gets a little messy because we have a lot of charges going on, right? I have 2 times plus 2. So I have plus 4 coming from that. I then have 14 hydrogen ions. So that's plus 14 more. Then I have 5 negatives, so minus 5. So 4 plus 14 is 18 minus 5. So we have plus 13 on this side. On this side, we have 2 negatives coming from here. We have 5 times 3, so plus 15 coming from here. 15 minus 2 equals 13. So we are balanced, right? Check to make sure you can't reduce. We have a 2, a 14, and a 5. We're not going to be able to reduce that, okay? All right, last one we are going to try is going to be this one. So you will find, if you look a lot online, they talk about basic balancing. we are not going to worry about basic balancing. Technically, this is a basic balancing question. However, there was 1 year on the diploma, which obviously, again, you aren't writing, I think I've said that a million times, where they actually put a basic balancing question on, but they expected you to balance it by acidic methods. And so unfortunately, some AP kids did not get that question right because they knew how to balance in basic, and they balanced in basic, and it was different stuff. So we're going to balance this in acidic, and I'll show you how that's going to look. But basically, it's the exact same thing, right? So we start by splitting. So the zinc is going to go into an equation with that zinc OH over the 2 minus. Okay, and then that ClO3 minus is going to go into an equation with the Cl minus. Okay, so we have that. We have 1 zinc and 1 zinc. We don't need to worry about the zincs. We have 1 chlorine and 1 chlorine. Don't need to worry about chlorines. Oxygen-wise, we have 4 here. So we are going to have to add 4 waters to that. Here we have 3 O's, so we are going to have to add 3 waters to this side. Okay, next step is take care of those hydrogens. I have 8 hydrogens here. I only have 4 over here. So we are going to have to add 4 hydrogen ions, right? So that we now have 4 plus 4 giving us 8, which matches those 8. Okay, in this one, we have no hydrogens over here. We have 3 times 2, so 6 on this side. So we are going to add 6 hydrogen ions to this side, okay? So now that we've done that, we need to count out our charges. This side has no charge. This side has -2 plus 4, so it's sitting at +2, which means we need to add 2 electrons over to this side, so +2 electrons. Okay, this one here, we have 6 positives and a negative, so we are sitting at +5 on the left side. We look over at the right side, this has a negative, that has nothing, so this is a -1. So to get +5 down to -1, we have to add 6 electrons. Okay, so now we brought the 5 down to the -1, so we have 6 electrons in this equation, we have 2 in this one. Lowest common multiple between 6 and 2 is a 6, so we do not have to multiply the second equation by anything. But we have to multiply this first equation, everything by 3. So 4 times 3 is 12, 1 times 3 is 3, 1 times 3 is 3, 4 times 3 is 12, and 2 times 3 is 6, okay? So now we've gone through, we have changed all those numbers. We now are going to add these together. So 6 electrons is going to cancel 6 electrons. I have 6 hydrogen ions and 12 hydrogen ions, so these are going to go away, and this 12 is going to turn into a 6. Okay, then our water, I have 12 and I have 3, so this 3 is going to go away, and 12 minus 3 is equal to 9. So then what we're left with is 9 waters plus 3 zinc plus that ClO3 minus, okay, turning into 3 zinc hydroxides plus 6 hydrogens plus that chloride ion. So let's make sure that it works. Okay, we have 18 hydrogens. And we have 3 times 4, so 12 plus 6, so we have 18. Sorry, for a second there, I thought it wasn't working, and I was like, what did I do wrong? Okay, so 18 hydrogens, 18 hydrogens. We have 9 oxygens plus 3 more, so we have 12 oxygens. We have 3 times 4, so 12 oxygens. We have 3 zinc and 3 zinc. We have 1 chlorine and 1 chlorine. So atoms, good to go. Charge-wise, I have a -1. That's the only charge I have on the left side. On the right side, I have a -6 coming from here because 3 times 2 is 6, so that's -6. This is +6. And here, this is -1. So these cancel each other. We have a -1 that matches my -1 over here. So my charges are also balanced, okay? So that is how you balance by half reactions. It tends to be a little bit more consistent, I would say. I know if I'm having trouble balancing a question, this is usually the method that I will go to. Although oxidation numbers is significantly faster, for me, I find that's where I tend to sometimes make mistakes, just because there's so many numbers all over the place. There's so much writing that sometimes you miscount something or you just make a small error. Whereas this one, I find it tends to be a little more consistent, and there's not as much going on all over the page, and so I find it tends to be a little easier. But I know some of you guys really like doing the oxidation number method, and if I was doing something really quickly, I would definitely do oxidation number method as well. But like I said, it really doesn't matter which method you choose. They will both get you to that exact same final endpoint. What is the most important thing is that you can balance, not that you can balance by both ways. So like I said, practice a few questions each way and see what feels more comfortable, right? Or maybe you find you really don't understand one, or maybe you find you like both of them and they both work well for you and you want to work with both of them. It's entirely up to you, but you do want to make sure that you are able to balance these redox equations, because they definitely do not balance by sight, right? Think about science 10 chemistry, think about chemistry 20, we just looked at stuff and balanced. We can't do that anymore when we get into redox. It's just not possible, okay?